Thank you for joining us for our water webinar, Ask ISCO, Troubleshooting and Optimizing ISCO Communication Devices. If you have any questions during the webinar, please utilize the Q&A functions within Zoom. All questions will be answered at the end. This webinar will be recorded and a video will be made available in the next few days. Today, we are very lucky to have two experts to discuss this topic. Our presenters today are Rich Skradski, Northeast Regional Manager, and Greg Hazen, Product Support Specialist. To begin this discussion, I will turn it over to Rich.
Welcome, everybody, and thank you, Sharon, for the introduction. And thank you to everybody who's joined us this morning for our webinar on troubleshooting and optimizing Teledyne ISCO communication devices. Before we begin in earnest, Teledyne ISCO would like to extend our heartfelt thanks to all of our essential water and wastewater professionals who are keeping these essential services operating during this health crisis. We know that many of you are selflessly giving of your time and exposing yourself to the coronavirus on a daily basis. Thank you. So why are we holding this webinar, and why now? As many of us are forced to work remotely, the need for reliable remote communication of samplers and flow meters has never been greater. In order to reduce site visits, it is imperative that these devices are working correctly and communicating remotely with your samplers and flow meters. The competition between telecommunication companies has pushed the industry to providing faster and faster service and networks. Last year, Verizon announced that it was switching from 2G to 3G across their entire network. This was originally scheduled to be completed by the end of 2019, but has since been extended to, at a minimum, the end of 2020. In response, Teledyne ISCO has upgraded all of our CDMA communication products to 4G LTE. So if you currently own our older 2G modems, we recommend that you contact your local service provider to verify that the cutoff date in your area so that you can plan and budget to upgrade to the newer 4G LTE modems. Currently, all Teledyne ISCO CDMA modems are 4G LTE. This includes our 6712 CI modem, our signature flow meter modem, and our 2100 series portable flow meter modems. Teledyne ISCO's GSM modems are currently 3G, but we are looking at upgrading these to 4G LTE as well. I'm sure that everybody has seen all the commercials promoting 5G networks. So why do we upgrade our modems with 4G LTE and not 5G? As we are seeing with Verizon, the switch is not occurring as quickly and universally as they would like you to believe. Even when the 4G is offered, the 4G LTE will continue to be supported. There were some other considerations made by Teledyne ISCO. Specifically, we needed to provide an immediate replacement for the older 2G modems that would fit into the footprint of our existing equipment. The 5G service wasn't and isn't available everywhere and is still sometime out in the future. More importantly, 5G may not allow text messaging directly from the modem for alarming purposes. This is an important feature and function of our modems that was considered essential. And 5G's first availability will be for commercial purposes, and we weren't sure if it would work through a manhole. Now, before I hand the webinar over to Greg, I want to provide a brief summary of the communication products that Teledyne ISCO offers and some definitions. Teledyne ISCO offers two types of modems, the CDMA modems denoted by CI and the GSM modems denoted by GI. The CDMA modems are predominantly used in the United States, while the GSM modems are predominantly used internationally. The I designates that the modems utilize an IP address to communicate. Previously, the modems communicated through an actual phone number. All of the Teledyne ISCO modems can send out alarms, they can collect data, and they allow for remote programming. As far as the modems that Teledyne ISCO provides and equipment that it supports, we have the 6712CI and the 6712GI, which provide remote communication with our 6712 portable and our 6712 refrigerated samplers. The 6712CI and the 6712GI will also work with our Avalanche portable refrigerated samplers. The signature modems, which are integral to our signature flow meters, are available in the CDMA 4G LTE and 3G GSM. The 2103CI and the 2103GI modems are for use with our 2100 series flow metering platform. They specifically work with our 2110 ultrasonic units, our 2150 area velocity flow meters, and our 2160 laser flow meters. And finally, the 2105CI and the 2105GI are interface modules with modems that allow for communication with other equipment and devices beyond the 2110, 2150, and 2160, items such as a rain gauge or a water quality sonde. One of the most valuable resources that Teledyne ISCO provides the industry is Teledyne ISCO's Product Support Specialist Group. The PSSG group fields many calls from customers concerning modem setup, operation, and troubleshooting. Oftentimes, the customer's assumption is that there's a problem with the equipment, when in fact, it's an application, setup, or service issue. When you're driving through the mountains and your cell phone loses signal, we don't blame the cell phone. We understand that we hit an area with poor coverage. When your computer's operating system becomes obsolete, we don't automatically assume that there's a problem with the computer. Instead, we begrudgingly upgrade. When your satellite TV goes out during the Super Bowl, and after we stop screaming, what happened? We don't go out and purchase a new TV. So why, when your modem stops communicating or the battery dies prematurely, do we automatically assume that the modem isn't working and at fault? Today, Greg Hazen is going to share with you an in-depth explanation of how to order a modem, how to program a modem in conjunction with a flow meter, how to program the modem to minimize power consumption, the different antenna options and correct antenna placement, troubleshooting steps, and some unique real-world examples where the modems were assumed to be at fault, but through step-by-step troubleshooting, the true cause was identified. With that, I'll now place the webinar in the very capable hands of one of Teledyne ISCO's PSSG experts, Greg Hazen.
Thank you, Rich, for giving me that introduction. I appreciate your background that you provided for the modems and Teledyne ISCO's products. Today, we're going to go over some of those portions that Rich just stated. We're going to go over the modem ordering first. So when you're going to order a modem for your Teledyne ISCO equipment, what is the first steps that you need to do? The first thing you need to determine is which phone service provider you plan to use. That will determine which type of modem you order, whether you're going to choose CDMA or GSM. The CDMAs typically would be Verizon or AT&T, T-Mobile, Rogers, Orange, any of those other companies from around the world for the GSM. But which ones you would choose depends on where your location is and maybe which service provider you're currently using for your company or municipality. If you have a Verizon account already, you're probably going to continue with Verizon. So when you look at the different areas of coverage, in larger municipalities may have about equal coverage between GSM or CDMA. In western Nebraska or more rural areas, the GSM coverage is a lot more sparse than the CDMA coverage, so you plan to probably use a CDMA modem or with Verizon out there. So once you've determined which version of modem, a CI or a GI, that you're going to purchase, you would contact the Teledyne ISCO customer service and place your order for the modems. They will ship you those CDMA or GSM modems will be shipped to you. Once you receive them, on each one of the modems that you receive, there will be an IMEI number, which is the electronic serial number of the modem. You'll need that from each modem to contact your service provider to set up your service. When you contact your customer, your service for your cell phone plan, we suggest getting a M2M plan, which is a mobile-to-mobile plan with text messaging enabled with unrestricted static IP. Now, what that means is the text messaging enabled allows you to receive text messages based off of alarms that you configure in your modems or in the flow meters that you have. The unrestricted static IP is what you would need to contact the modems in the field remotely after they've been installed. So you'd want to connect with FlowLink into your signature meter to retrieve the data remotely. You need to have a static IP so your computer and the signature are able to talk to each other on the internet. The provider will then ship you the micro SIM cards for your modem. So this picture here of what they kind of look like, there's some little metal contacts on one side. The other side's usually blank or has some numbers on it as well. You're going to install that SIM card inside your modems and connect the antenna. Then you need to configure the modem with the correct APN or access point name and any data push information like as a server IP address and the port and the call-in windows if you want to connect via that static IP at the future, in the future. Then you're going to cycle power on the units to, once they come back up, they're going to connect to those networks, the cell service provider networks, and then be able to connect to it via FlowLink, via static IP, or push the data into the network. So the next thing you want to do is verify that you're getting data pushed into your server if you have a FlowLink Pro server, or you're able to connect to it via that static IP. Now, we do offer a service as part of Teledyne ISCO if you don't want to go through the part of doing the configuration and making sure that it's already tested before you get it. This is a way we used to do it when it was a 2G modem, so it's kind of along those lines. So if you do want Teledyne ISCO to test the modems with your service prior to shipping them to you, you would contact Teledyne ISCO, place your order for your modems just like before, but you would also purchase a part number called cell activation. Now that would be for each modem you want to have configured. Teledyne ISCO will then send whoever you set as the customer contact at your company or municipality with the IMEI, which is the serial number of the modem, and the CCID, which is the serial number of the SIM card, from the SIM card that we have at the factory. We're going to provide that to your customer contact. The customer should then contact Verizon or the Verizon group to get the cell service set up with that IMEI and the CCID number to get the data plan, the static IP, and your text messaging service set up. Once that has been set up by Verizon, you will then contact back to Teledyne ISCO. You'll provide the phone number and the IP address that Verizon gave those devices to contact back to Teledyne ISCO for us to do testing and verification of that service. The activated and tested modems are then shipped to you, the customer. Now, this is only for Verizon cell phones. We offer that service for Verizon cell phones or the CIs or the CDMA modems. So just to make sure you know that this is for Verizon only. So how do we install the SIM card? Now we're going to go through a couple of the different devices that we can do that with. The 2100s CDMA or GSM modems all have a slot for the SIM card in the bottom of the units for the modems. So what you're going to do is there's a little door on the bottom. You'll use a coin or a tool to rotate the cover counterclockwise and remove the cover. Inside, you're going to find the little SIM card holder you'll pull that out. It's just attached with Velcro to the circuit board. So you'll pull that out, and you can see a picture right here on the board or on the ribbon cable that shows you how the SIM card should be inserted. Now you'll notice that you don't see the metal contacts from our picture before because those are pointed down to make contact with the ribbon cable itself. So make sure you insert it so the picture and the SIM card look the same. Then you replace the SIM card back into the unit, put it back on the Velcro, and replace the cover. Now the signature CI/GI modems and the 6712 CI/GI modems both are pretty much the same, except you will see those inside of the signature case installed on the back of on the inside of the unit of the case. So you have to open the signature up to get to the area where the modem is. And also, or the 6712 CI or GI, you have to remove some screws off the cover for the little gray box that it's in. But as you can see, it's pretty much the same. The SIM card is inserted the same way into the same holder, and you can see there's a picture on there to help guide you to put it in there correctly. Just to go through the APN configuration. Now, a little more information on the Verizon is in this part, just because we deal with a little more Verizon cell phones than GSM ones. But as you can see, Verizon has divided the United States up into 4 separate areas for the APN, or the access point name. So where you're located at may not determine this. What determines this is the area code of the phone number that Verizon has assigned it. So if your area code is for somewhere in Florida, you would use the SO01.VZW static. So I'm going to jump forward here. These are some of the choices that you would use. If you are using a static APN, you would use one of these 4 up here. That all have the VZW static on them. If you're using a dynamic IP, which means you don't plan to connect to the modem via the internet, via IP address, you would use VZW Internet. Now, these are the choices that you would have for Verizon. If you have, say, AT&T, T-Mobile, Orange, Rogers, they all have their own APNs that you plan to use. And those companies, when you purchase the data plan, would provide you with the correct APN to use. One of the examples for AT&T would be I2 Gold. So just to give that example for you there as well. To configure the APN in the devices with the 2103s and the 2105 CIs and GIs, you connect to the stack of your 2100 with the modem, connect to it with FlowLink, and go to the modem tab. You would go to the modem tab. So on the modem tab, you'll find a place for the APN to be typed out into on the APN configuration. So you would take your APN that you figured out from before and put it into the 2100 here and do the apply. Once you've applied it and it's saved the changes, you'll disconnect power and then apply power again. By doing that disconnect and reconnect of the power, it forces the modem to ask for its APN from the device and then go out to the network. On the signature meter, there you will go into the menu, hardware setup, modem setup to put in the correct APN. So you'll put that under the access point name. Once you've configured that APN and done a next to save that, you would also cycle power on the signature meter so that it connects to the network. The 6712 APN configuration is done a little bit differently. You connect to the 6712 sampler head itself using a terminal program and a connect cable. That terminal program could be like HyperTerminal, TerraTerm, PuTTY, one of those. Once you connect to the 6712 sampler head, you enter the command APN, and you'll see that you would be allowed to put in the APN name. Once you've done that and saved it and exited out of those commands, you just put the cable on the back of the 6712 from the 6712 CI. It powers the modem up there, and it connects to the network. Now, modem power consumption. modem power consumption is a big thing out there in the world if you're using modems that are using battery power versus AC powered all the time. You want to get as much battery life out of your deployment as you can instead of having to change batteries out more often. Now, one of the ways you can do that is set up a data push. So if you have a FlowLink Pro server that you're able to push the data to, you can put that information in there and it will push every, by default, whatever you want to put in there, 4 hours, 2 hours, 12 hours. By doing that, it just connects, pushes the data and disconnects and goes back to its normal routine of just using the power to take readings. By doing that, you're not leaving the modem on all the time. It's only powering up to push the data and then powering down the modem. If you need to connect, and we call that a data push, a data pull is when you have to set up a call-in window. This call-in window is a time equation, a timetable equation in the meter that turns the power onto the modem to listen to an incoming static IP connection. During that time, the modem is powered up the whole entire time. So say you configure it from 8 a.m. to noon every day to listen for you to connect in via IP address. It's consuming more power during that time because the modem itself is connected to the network and listening for an incoming connection. By making the windows as small as you can, but are still valuable to you to be able to connect during that time if you need to, or to download the data. By narrowing the window down, you're helping conserve your battery life. To set up a call-in window in the 2100s, you would go to the tab that says Wireless Power Control, right there at the top, and then you would click on the button that says Configure Power Control. This takes you into an area where you can set up the equation for a timetable condition based off of Monday through Friday or every day of the week from whatever time to get your window set up. The signature flow meter, you can set up the equation for that call window under the exact same place where we did the modem setup. There's a little button at the bottom under the menu, hardware setup, modem setup. There's a button under the equation to set up that timetable equation as well. By default, in the modem wireless window, in the 2100s and 2103 CIGI and 2105 CIGI modem, there is no power wireless window configured. That, by default, we don't turn on a window. So that way, if you're always just pushing the data, you're only seeing that data being pushed to the server versus if you wanted to set up a wireless window, you're allowed to do that at some point in time in the future, but by default, to save power, we don't set up a wireless window. A portable signature with a modem has a default wireless window configured when you set it up between 9 a.m. and 10 a.m. every day of the week. You can go in and change that if you'd like, but that's one of the things that they just set that up by a default just to save you power, but also give you a way to connect into the signature. AC powered modems with powered signatures with modems are always powered. So they never turn on a wireless window. You can connect to them at any point in time. So because they've got AC power, battery consumption is not a question. The 6712 CI and GI modems, they have a default set that the modem is always powered and it checks for a message every 5 minutes. So if you send it a text message to start a program, you're able to see that as well. For antenna connections and placement, LTE modem antennas use a higher frequency. All the 4G LTE antennas have a white connector end. And you can see that circled here on the antenna. So it's a white connector end. That's what you would want to use for any of the 4G LTE modems. The older antennas with a black connector end may work with a 4G LTE modem, but they're not optimized. So you're not going to get as good signal strength as you can with the 4G LTE white modem connector ends. So for best wireless signal strength, make sure you use the LTE modem connector end. The antenna also needs to be placed in a vertical orientation. The signal that comes out of an antenna is out of the sides, not vertically out of the top. So always make sure that you understand that the signal is coming out of the sides of the antenna. Also, do not kink the coax cable, meaning when you have to wrap it up in a loop, make sure the loops are of any excess cable are larger than your fist in size. When you go to install these in a manhole, the best location is about 4 to 8 inches beneath the metal rim. So making sure your antenna is down below the 4 to 8 inches and closer to a sidewall, as you can see from the picture here, allows the signal to get out through the dirt or the concrete easier than it does to which the metal cover of the manhole blocks it more than the concrete or the dirt does. Some of the modem troubleshooting that we need to do is first of all, we want to make sure that the SIM card is inserted correctly into that slot. If we find that sometimes that the customer has accidentally turned the SIM card over or put it in upside down, or the slot is inserted first, it's on the card. So making sure, follow the picture of the SIM card on the ribbon cable, and also to make sure those contacts are down towards the pins that you're inserting it into the connector. Making sure you're using the correct LTE antenna with the white connector. That will give you the best possibility of the best signal strength to reach a tower. The signal strength being greater than 20% is especially needed for getting out of certain troublesome areas, but we like to see anything greater than 20% signal strength to get the best signal. Making sure that you have programmed the APN correctly. Mistyping or finding that Verizon meant for you to use a different APN. Those are things to confirm with your cell service provider, and also to just check that what you've put it into the modems, what you have put into the modems is correct. Making sure that the cell service has been configured properly by the provider. Sometimes the Verizon maybe forgets to do something on the setup of the plan. Sometimes just by contacting them with a known good working modem or SIM cards plan and having them compare, sometimes that will fix any issues you have as well. Swapping one modem for another modem that may be working. So maybe you have a good modem out in the field and you're putting this new modem somewhere else and it's not working. Maybe just swapping the two modems at the two locations and see if the problem stays with the location or follows the modem. Swapping SIM cards. So if you have a known working SIM card in a modem, putting it into this modem to try and make it work, sometimes that will help you troubleshoot where the issue is. Now, if your problems persist, we are happy to help you out in the product support group. You can reach out to us Monday through Friday from 7 a.m. Central to 5 p.m. Central Time at 866-298-6174, and one of our technicians would be happy to walk you through any of the troubleshooting steps and find any issues that you may have. Just to give you some real-world examples of where the customer was concerned that their modems were not functioning versus whatever we would find here in the end. We had a customer that called in with a problem with several new modems they had purchased that were not pushing into their FlowLink Pro server. Now, they had other modems currently at the time that were pushing into the FlowLink Pro server, but these new modems would not push. The customer was concerned they had problems with these new shipment of modems. The modems would not connect via static IP or push data into the server. So what customer product support group did is we connected to the modems remotely and verified the modems were connecting to the provider's network, meaning they were reaching Verizon or AT&T. So we were getting on the AT&T network. But when they connected to or tried to connect to the customer's network to reach the FlowLink Pro server, they were not reaching the IP listener to send data into their server. What we found was that something in the customer's firewall configuration and parts of their network were blocking these new modems from reaching the IP listener. So it could be as simple as there's a firewall that's only allowing certain IPs of modems through. Well, the customer purchased new modems. They needed to reconfigure their firewall to allow these new modems to reach into their network. Another example here is a customer's modems were working fine when they were in the office or when they deployed them to certain areas, but all their locations were not working when they were deployed. We were able to connect to those modems remotely and troubleshoot them and verify that, yes, they were indeed working while they were in the office. We also then had them go and take them out to the field where we also connected to them, and we verified that there was no service for those modems in certain areas. What we found with working with these, that they were actually the older 2G modem versions. So in those certain locations that they were installing these older 2G modems, there was a hole or no service at that area from the cell phone towers that would normally give 2G service. They had been discontinued in that area. And when the customer would move them around, they would work in some areas and not. When they purchased new LTE modems, they were able to get service in all their locations because now the 2G service was not an issue. They had the 4G LTE modems. We had a customer that also called in and stated they were having to replace their site batteries very often, and sometimes the modem stopped pushing data in from the field intermittently, so they had to make a lot more site visits and change out batteries and get the modems working again. We were able to connect to many of the modems in the field based off the IP addresses the customer gave us and verify all their programming and that we were able to connect to some of them. They were also able to give us their database, so we were able to look at the battery life that they said they were seeing, that it would drop off over time or quickly drop off after a little bit of time. What we found is the customer had these set up in a sites that were more of a stormwater or an overflow type situation. What it was is they wanted normal push rates pushing in every 4 hours or every 12 hours actually, I believe. And once those modems would push in those data, every 12 hours when there wasn't an event, they would push in every 12 hours. But when there was an event triggered of some sort of level rising of a certain amount, they wanted it to push more often, so they set up what's called a secondary data push rate. So their primary rate was 12 hours, their secondary was about every 30 minutes or 1 hour if the triggered condition of level being greater than a certain amount was reached. When we looked at those triggers, we found that to untrigger it, they had placed what's called the hysteresis as a very large number, so it was no possibility that those units would ever stop pushing at that faster rate, even when the condition went away. So what we had the customer do was change those configurations, because once we saw that those triggers were happening, we could see the battery life dropping off very quickly because those were pushing in more often. So once the customer has changed that configuration, they've seen a reduction in their battery usage. So if everybody would like to type in any questions into the Q&A feature of the meeting, that would be great. We will answer those as many as we can and as completely as we can. So we appreciate. Thank you, everybody. Yeah, if you could just type into that question and answer. I will answer some of those questions. I also have some that were sent in ahead of time. So I will step into those as you type in your questions. We appreciate those. We'll answer those as well. Got one here that asks a little more about the secondary data push rate. What is a secondary data push rate? So if you have a secondary data push rate, again, it's going to push in more often based off of some sort of condition occurring. But the secondary data push is not dependent upon if you have, say, an alarm setup. So say you have an alarm set up to receive a text message or something like that, or receive a server alarm message based off of some condition. If that happens, it will push in right when that condition occurs versus setting up a secondary data push rate. got another one here that what is the alarm and secondary data push the same thing? Not exactly the same thing. The secondary data push is just sending the data to a FlowLink Pro server more often, whereas an alarm condition is, hey, I want to send an alarm based off my level going up a certain amount to send either a text message directly from the modem itself or from the FlowLink Pro server, send an email or text message from there. Aware of any the best network provider for working with CDMA or working with GSM modems in Canada. I know that I've heard Bell, Rogers. Those are the two main ones I've heard in Canada. I don't have a lot of experience. I've talked to a lot of people as they were setting them up, but those are the two that that I hear used most often. As long as you've got the correct APN for those modems, you should be able to configure them, get the data sent to a server, or download the data via static IP if that's how you configure that with Bell or Rogers. So those are two of the providers I know from up there. Has the switch from 4G to 5G been pushed out? There really isn't the 4G to 5G. I believe 4G, as Rich said, is going to be around for quite a while, from what I understand from Verizon. It's the 2G service and ultimately the 3G service for Verizon. I believe that they are phasing out slowly. And as Rich said, the end of 2019 was supposed to be the end of 2G service for Verizon, but I believe they pushed it out for a majority of people or majority of the areas to this year in December. So we'll see what happens with that. There's a question about purchasing 4G antennas. You can contact your local sales rep if you'd like to get in touch with them. I'm sure they'd be able to help you out by ordering those antennas, or even contacting our customer service. They'd be happy to help you as well. Let's see here. Can FlowLink be installed on a virtual server? It's not really the modem question, but yes, it can be. FlowLink Pro could be installed on a cloud server, AWS, Azure. I've seen those done, as long as you can set up what they call an elastic IP, or it's almost like a static IP on the server. You can actually push your data from the field into those FlowLink Pro servers in the cloud. So I've seen that done. I've helped configure those. So yes, that is a possibility as well. Got a question here that in the 2103, they are not seeing signal strength when they're connected via static IP. That is the case because when you're connected via static IP, you're actually going through the internet, going through the cell phone and connecting into the module, the meter. What's happening there is the module or the modem is not able to ask the tower what its signal strength is. So the modem and the cell tower has to be talking in a way to ask that question. If you're already connected in using the modem, it doesn't have the ability to ask the tower what its signal strength is with commands. You're busy consuming its communication lines with your downloading of data or talking to the module. Is it possible to get alarm from a modem but no data is pushed into a server? Yes, if the FlowLink Pro server is not receiving data, but you have a text messaging plan enabled on that cell phone, you would then be able to see the data getting to the server, or not getting to the server, I should say, and you would also still be getting an alarm via text message. So they still can work together. It's just if the server is just not working in the way to get the data in, maybe there's a firewall blocking it, IP listener or something like that, that would be something to troubleshoot to see what's going on. Question for setting up a scheduler and its setup. The scheduler is a program used within FlowLink. We didn't really talk about that in the webinar, but we can quickly touch on it here for you since somebody had a question. The scheduler service in FlowLink or FlowLink Pro is a way to schedule a connection via the static IP out to the meter in the field to download the data, and then it disconnects. So it's a way for you to set up in the scheduler in FlowLink Pro or FlowLink Pro, you would set up a task within the schedule to retrieve data, say every day at 8 a.m. So every day FlowLink would run that service to connect via the scheduler, download the data and put it in the database and then disconnect. If you need more comments on that, you just give us a call at product support. We'd be happy to help you walk through that. Let's see here. I got a couple more. I appreciate everybody's time, and hopefully we can get to all your questions here. I know this sometimes is a very technical thing. I've got a question here if we provide SIM cards. Yes, we do. At the very top of the webinar, we do a service for Verizon only. So we would provide SIM cards for Verizon only, and you would contact Verizon and set up your service, give us some information. We'd use the SIM cards we have in the factory, program them, and test the modems before we ship them out. You would just use a part number called cell activation again when you place your order for your modems, and that will flag them to do all that on the backside in the factory before we ship them to you. If I need to make a connection via a static IP, what port ranges do I need to be unlocked on my network? This is one thing we see occasionally on the network on a customer's network. If they've really been locked down by their IT department for security-wise, they'll sometimes block the outgoing and incoming ports that FlowLink can use to connect to the meters. The meters by default are set up to use port 1700, so 1700, which FlowLink by default uses when it tries to connect via static IP. So if your network is being blocked, your firewall is blocking that, you won't be able to connect via static IP to the meters in the field. So making sure that one is open, or you can actually program any of the meters to be a specific IP or port number you'd like to use. Let me see here. Asking about using a dynamic IP configuration. The dynamic IP would only work for a 6712 CI or GI modem. That modem has the capability or the programming to send it a text message, and then the modem wakes up, grabs an IP address from the provider, self-provider, and sends a text back to you with the new IP address, and it keeps it active for about 15 minutes. That way you're able to connect in remotely using a dynamic IP. The signatures and the 2100s, 2103s do not have the capability to send it a text and have it pick up and then grab an IP address. For those to connect remotely, you would need the static IP. Maybe a couple more questions here if you want to get them in here quick. I got maybe one or two more, and then we'll end the webinar here in just a couple moments. A rule of thumb about setting any hysteresis levels, like the one where we had the problem one. Not really a rule of thumb, it's more on your application. The application you're involved in, maybe there's a certain rise that you want to reach that certain level, and then when it drops below, you want it to untrigger it. You'd always want to make sure it's possible, like in that one problem we had, that it's always possible to drop all the way down below your hysteresis level before that untriggers the equation and then goes back to whatever condition you normally have. Really no rule of thumb on that, but it's just one of those things that if you have questions about that, we kind of help with applications as well, so give us a call at the product support group. Looks like I have run out of questions here. So I personally want to thank everyone for joining us today, and I hope everybody learned some new information. And if they have more questions, please contact us. I'll turn it over to Sharon to end it out. Have a good day.
Thank you, Greg. Thank you all for attending our troubleshooting and optimizing ISCO communication devices. We greatly appreciate Rich and Greg providing us all of this important information. It was recorded and a video will be made available. If you have further questions regarding this webinar, please feel free to reach out to me through Zoom and I'll forward it on to the correct person. If you would be interested in receiving an attendance certificate, please also email me. Provide the name of the webinar that you have attended, and we will get that emailed back to you. Thank you again for joining us. Stay healthy and have a great rest of your day.